Hi, welcome to the mathematics in my channel. Today I am going to discuss about another interesting topic, imaginary derivative of x. Okay, first I am going to take the general formula for kth derivative of x to the n. So d by dx x to the n. So general power rule, we know this is equal to n times x to the n minus 1. Okay, now second derivative, so this is equal to here n and then n minus 1 times x to the n minus 2. Okay, now again differentiate. So third derivative, dx to the third x to the n. So this is equal to n times n minus 1 n minus 2 times x to the n minus 3. Okay, now here n minus 1 n minus 2, and now I multiply by n minus 3 n minus 4, and this is going to 2 times 1, and also divided by same term n minus 3 n minus 4, this is going to 2 times 1, and here times x to the n minus 3. Okay, now we know this is equal to factorial n, and here n minus 3 factorial times x to the n minus 3. Okay, this is equal to third derivative of x to the n power. Okay, now we need to find the kth derivative. So replace k for 3, so we can write dk over dxk x to the n power. This is equal to n factorial over n minus k factorial times x to the n minus k power. Okay, now factorial define, we know definition of factorial, gamma function. So n factorial is equal to gamma of n plus 1. So we can write this equation by gamma function. So dk over dxk x to the n, so this is equal to here n factorial, we know gamma of n plus 1 over gamma of n plus 1 minus k times x to the n minus k power. Okay, here in this formula k can be any real number. Okay, this is the general formula for kth derivative of x to the nth power, and here k can be any real number. So get an idea. Now I am going to find the half derivative of x. So here, now if we find half derivative of x, here k is equal to 1 half and n is equal to 1. So we can write d, here k is equal to 1 half over dx to the 1 half x, because n is equal to 1. So here gamma of n is equal to 1, so gamma of 2 over here gamma of, now n is equal to 1, so 1 plus 1 minus k is equal to 1 half times x to the n is equal 1 and k is equal to 1 half, so 1 minus 1 half. Now we know gamma of 2 So we know n factorial is equal to gamma of n plus 1. So gamma of 2 is equal to 1 over here gamma of 1 plus 1 2 2 minus 1 half, so 3 over 2. Here x to the 1 half. Now gamma of 3 over 2, we can write this is equal to 1 half times gamma of 1 half x to the 1 half. Okay, now half derivative of x is equal to here 1 over 1 over 2 gamma of 1 half square root of 5 x to the 1 half. So this is equal to 2 times square root of x over square root of 5. So this is half derivative of x. Okay, now another interesting point. So if we take half derivative of this term, so d1 half over dx 1 half 2 times square root of x over square root of 5. So this is equal to 2 over square root of 5. Now gamma of here x to the 1 half, so 1 plus 1 half over gamma of 1 half minus 1 half plus 1 times x to the 1 half minus 1 half. Okay, this is equal to 2 over square root of 5 times here gamma of 3 over 2, here gamma of 1, and here x to the 0 power, so this is 1, and this is equal to 2 over square root of 5 times gamma of 3 over 2, we know 1 half square root of 5 over gamma of 1 is equal to 1. Okay, now square root of 5 get cancelled, 2 get cancelled, and this is equal to 1. Okay, next, now another interesting point. So if we take d1 half over dx 1 half times d1 half over dx to the 1 half x, so this is equal to, now we know 1. So another notation for this, d capital D 1 half capital D 1 half x, this is equal to 1. So generally we can write d n plus d n2 x, so this is equal to d n plus 1 n2 x. Okay, here n1 and n2 can be any real number. Okay, we proved general formula for kth derivative of x to the n and works for real number, and we found half derivative of x, and now we are going to find the ith derivative of x, so imaginary derivative. Okay, we proved general formula, which I write here, d k over the k x to the n, this is equal to gamma of n plus 1 over gamma of n plus 1 minus k times x to the n minus k. Okay, now we know generally factorial only work for integers, but if you like to work with complex numbers, you can do it, because this is valid for any real and complex numbers. So we found half derivative of x, here 1 half is a real number, and then we can try with a complex number, Okay, now we are going to find the ith derivative of x. So here k is equal to I and n is equal to 1. So we can write di over dx to the I, here x because n is equal to 1. Now this is equal to gamma of n is equal to 1, so gamma of 2 over gamma of, again now n is equal to 1, so 1 plus 1 2 minus k is equal to I, so gamma of 2 minus I, here x to the 1 minus I. Okay, now gamma of 2 we know 1 over gamma of 2 minus I x to the 1 minus I. Here di over dx to the I x, and now I am going to take this is equal to 1. Okay, now very interesting. And what can we do? Okay, here we have 1 over gamma of 2 minus I and x to the 1 minus I. Okay, first I am going to take 1 over gamma of 2 minus I. So 1 over gamma of 2 minus I. Now we can write here 1 over gamma of, this is equal to 1 minus I plus 1. Okay, now we know gamma of z plus 1 is equal to z times gamma of z. So we can write this is equal to 1 over 1 minus I times gamma of 1 minus I. Okay, now we can multiply by 1 minus I conjugate, so we can write 1 plus I over 1 plus I times 1 over 1 minus I gamma of 1 minus I. So this is equal to here 1 plus I over, now 1 plus I times 1 minus I. So here 1 minus I square, so 1 minus minus 1, so 2. So 2 times gamma of 1 minus I. Okay, I rewrite here 1 plus I over 2 times gamma of 1 minus I. Okay, we started by 1 over gamma of 2 minus I. Now we have 1 over gamma of 1 minus I. We know Euler's reflection formula. So gamma of C times gamma of 1 minus C is equal to 5 over sine of 5z. Okay, now we need gamma of 1 minus I. So I substitute I for z. So we can write gamma of I times gamma of 1 minus I. This is equal to 5 over sine of 5i. Okay, now again sine of 5i. What can we do? Yeah, we know sine of c is equal to e to the iz minus e to the minus iz over 2 times I. Now we need to sine of 5i. So I substitute 5i for z. So sine of 5i is equal to e to the here z is equal to now 5i, so 5i square, so minus 5 minus e to the, now z is equal to 5i, so 5 times I square, so minus, so plus I, so plus 5, so plus 5 over 2 times I. Okay, now sorry, okay, now if we multiply by I, so here I times e to the minus 5 minus e to the 5 over 2 times I square is equal to minus 1, so minus 2. Okay, now I write this place, so now here we can write this is equal to I times e to, here minus we can multiply by minus sign, so e to the 5 minus e to the minus 5 over 2. Okay, now we know this is equal to hyperbolic of sine of 5, so sine h 5. Okay, now we can substitute here, so we can write 1 plus I over 2 and 1 over gamma of 1 minus 5. So we can get it here, gamma of 1 minus I, so 1 over gamma of 1 minus I is equal to gamma of I times sine of 5i over 5. Okay, now we can write 1 plus I over 2 gamma of I and sine of 5i. Sine of 5i, we found it, sine of 5i is equal to I times hyperbolic sine of 5, here 5, so I write here. Okay, now here in the equation number 1, now we simplify 1 over gamma of 2 minus I, now we have x to the 1 minus I. Okay, now we can write, now we can write x to the 1 minus I, so this is equal to, we can write x times x to the minus I. Also we know x is equal to e to the natural log of x, so we can plug in here, this x is equal to e to the natural log of x to the minus I power. Now here natural log of x and minus I are powers, so we can multiply it, so x times e to the minus I times natural log of x, so x times, now we can write this is equal to cosine of natural log of x plus I times sine of minus natural log of x. Okay, now we know even and odd function, so we can write x times here cosine of natural log of x minus I times sine of natural log of x. So now we can multiply by x, so x times cosine of natural log of x minus I times x times sine of natural log of x. Okay, now we simplified x to the 1 minus I. Well, okay, now our equation number 1 I rewrite here. Di over dx to the I x is equal to 1 over gamma of 2 minus I times x to the 1 minus I. Okay, now gamma of 2 minus I we simplified here, so I rewrite this. So this is equal to 1 plus I over 2 times 5 gamma of I times hyperbolic sine of 5, and we simplify x to the 1 minus I, so this is equal to x times cosine of natural log of x minus I times x sine of natural log of x. So I rewrite this, so we can write here x times cosine of natural log of x minus I times x times sine of natural log of x. Well, now this is the ith derivative of x, but now we have gamma of I. How can we evaluate it? Okay, you can evaluate gamma of I by this integral. So 0 to 5 over 2 fractional part of cot of x dx 1 minus 5 over 2 plus I over 2 natural log of 5 over hyperbolic sine 5 times gamma of I square. Okay, if you want, you can evaluate gamma of I by this integral. Here fractional part of cot of x, so here I derivative of x. Okay, very interesting. Thank you for watching. If you like this video, please subscribe this channel.